Well, hello, good afternoon, everyone, and good morning to those on the West Coast. It's great to have you with us today, and I cannot think of a better day to be hosting a webinar on AI and transportation, given the executive order that just came out yesterday and the conversations that have permeated pretty much every corner of transportation over the past several months, and certainly in the past several days. So it's my pleasure today to bring to you this webinar. And it's my pleasure to introduce Renee Ray, who is the Senior Director of Transportation Policy at Hayden AI. And she actually wrote a paper on AI and transportation for the Eno Center. And we wanted to really highlight the work that she did because it really lays out the different methods of AI and how AI is and can be used in transportation to improve transportation. I've known Renee actually for several years. She's been in the transportation technology industry for about 15 years. I've known her for quite some time in different capacities. She's always been an advocate for innovation in this space. She's always been an advocate for more women and diverse voices in this space. And now with her newest stint at an AI-based company, we're really excited to hear her perspective, hear about the paper she wrote, and then also share the use case of what Hayden's doing among other use cases in AI and transportation. We are going to have questions and answers after the presentation where I will ask Renee some questions, and we are going to open up to the audience. So please be thinking about the questions you want to ask. And with that, I will turn it over to Renee.
Great. Thank you so much, Laura. I'm very excited to be here this afternoon for me here on the West Coast. I'm going to start with just a little bit of background about why I wrote the paper. So as Laura mentioned, I've worked at a startup for 2 years that currently uses AI to help transit agencies improve their operational performance. And I'm someone who is frequently reading news stories about AI and sees the way that AI is being used in terms of, consumer products like recommendations for, what to watch on Netflix, for example. But frankly, I felt like there wasn't a lot of clear information about what AI is, how it's being developed, and how it might apply to me as a transportation practitioner, and someone who, knows the product that my company sells, but otherwise, is trying to read popular media to understand artificial intelligence. It didn't feel like there were a lot of great resources to do that. So basically, I wrote this paper because I wish I had been able to just read it a year ago and understand the industry better. And I think too, most folks who think about how AI is being applied in transportation are going to think about autonomous vehicles, but there are a ton of other applications across the industry and across different modes. So part of the paper diagrams what some of those examples are. So I'm going to start with what really resonated with me in terms of trying to think about what artificial intelligence might mean and how practitioners might use it in their role. One of the important things to know about artificial intelligence is that the definition changes over time because the technology matures and changes. So things that might have been considered AI 20 years ago may no longer really fit that definition. They may be something more like a computer science principle. But the two main things to think about in artificial intelligence are that you're talking about autonomy, so the ability to perform tasks in a complex environment without constant human oversight, and adaptivity, which is the ability to improve performance over time by learning from experience. So if you've heard of machine learning, that's going to be an example of that kind of adaptivity. And really what artificial intelligence is about, its purpose is you're solving a problem that you probably wouldn't or couldn't or would choose not to solve with people. And so the way that broke down most easily for me is to think about problems that could be involving numbers, so a data set. It could be something like words, so like a large language model like ChatGPT, or it could be a problem that involves images, so a video of the built environment. And if I'm thinking about my role as a transportation practitioner, I'm trying to solve a problem to perform my job better. The input is going to be, these words, these images, or these numbers, and there are just different methods of artificial intelligence applications that I could apply to, one or two or all three of these different data sources to try to solve my problem. So that framework really helped me visualize all of the different use cases for artificial intelligence and all of the different applications. So this is a diagram pasted from the paper. It's only a portion of the AI methods that are in use today, but it's some of the ones that are either most common or most used within transportation. So you can see that like artificial intelligence fits within this larger computer science framework, something, an industry that's been around for, 50, 75 plus years. And so artificial intelligence fits within computer science, and it includes all of these other methods. So I mentioned machine learning, which is the ability to change over time, to take inputs, to learn from previous solutions that an algorithm has developed, and to continue to improve performance over time. You can think about computer vision, so that, you're going to think images, right? So the ability for computers to look at either video or static images and start to draw inferences or interpret those images and derive some value from them at a really fast pace and in a really short amount of time. Deep learning is one of the fastest growing and now most common methods. It can use either the images or data or other words, but it's basically the next level of machine learning. And one of the challenges for deep learning is that it's a little bit, it's the machines, the artificial intelligence is moving so quickly that complete transparency in terms of all of the calculations that are done to date is not something that's very commonly shared within deep learning. And so that's one of the more challenging tools that you might use in a public sector space. And then finally, you can see this convolutional neural network. So that's a combination of many of these different methods. And I think when you view this diagram, you start to see the complexity because these methods fit within a larger framework of, sometimes it might be computer vision, sometimes it might be machine learning, but they're interlapping, they're overlapping, and there's a ton of complexity in terms of all of these different tools and the pace of change with which these tools are being created and developed and implemented, particularly in the past couple of years. So I'm going to move to, I have a table that was large enough that I couldn't fit it onto a single slide, but it basically shows you some examples for how most of the diagrams most of the images on the previous diagram and some additional artificial intelligence methods either can be or are already being applied across the transportation landscape. So for instance, you can see something where convolutional neural network is something that you could apply to satellite images and to weather radar, and that might improve aviation operations because folks that are trying to, manage airplane traffic have a more precise understanding of weather that's happening and how they need to change their operations in real time to adapt to a changing situation. You can see something like natural language processing a little further down. That might be something like a chatbot. So before this webinar started, Laura was telling me about how when New York City announced the launch of its AI plan, they actually deployed a chatbot to do robocalls in 65 different languages based on the dominant language spoken in different New York City households. So that was a way to use a chatbot to inform the public about a particular plan that the city was releasing. I'm going to switch to the next half of the table. And again, this is cut and pasted directly from the report. So it's something, if you go to the link, you'll be able to find and have as a reference point. So there are a couple of different learning models that artificial intelligence uses. So you see reinforcement learning, semi-supervised learning, and supervised learning. and unsupervised learning. And that really relates to the level of sophistication of the artificial intelligence method. So something like supervised learning, you can think of that as a more nascent use of an artificial intelligence method where, because it's new, because there's not an existing large data set of previous experience, you're going to have more human oversight, human intervention in terms of developing software, correcting a machine learning algorithm to say whether or not a result that an AI tool comes up with is correct or not. And as the tool progresses, the method of learning can go from supervised to semi-supervised to unsupervised. And you see a couple of examples there. So I'm going to move on to just the example of how Hayden AI uses a couple of different artificial intelligence methods to solve a problem for a transportation agency as an illustration of what these tools actually look like when they're deployed in real life. So there's a current problem that some transit agencies have, which is they've invested in dedicated bus lanes, or they have bus stops that are inaccessible because vehicles are illegally parking in those lanes or in those stops, and the bus operator is having to weave in and out of traffic. It's slowing down the bus performance, and in the case of bus stops, can make them inaccessible for a rider with a disability trying to board or exit the bus. So a solution that Hayden AI provides is basically leveraging several different artificial intelligence tools in a piece of equipment that goes on the bus that gathers data, that captures data, that interprets it in real time and pushes it to the cloud. And so the outcome that some agencies see, in this case, New York MTA, which is a client of ours, is that basically by adding this AI-powered solution, they're seeing an increase in bus speeds, improved on-time performance, and actually a reduction in collisions. So thinking about that problem that you're trying to solve with AI, one of the challenges in transportation is that you frequently, you're gathering data, in the road infrastructure, the street network that a city or county has invested in. So in order to be able to use AI to help agencies remove illegally parked vehicles, you have to know what's happening on the street, right? So in our case, we take a couple of different cameras and a J1939 plug. And what that does is the cameras are on, they're focused on the street in front of them. And when the bus is on, the cameras are on, they're viewing what's happening on the street, and they're pulling data from that J1939 plug to say, where is the bus in time and space? You've got this AI perception engine that acts like a computer on the bus, and the cameras aren't just recording video all day long. They're actually interpreting in real time, is there a dedicated bus lane or a bus stop here? Are there business rules in effect at this day and time that impact whether or not it's even legal to enforce this particular piece of right-of-way? If that seems to be the case, is there a car that appears to be illegally parked and blocking that vehicle? Only then does the perception engine actually capture a few seconds of video. It transmits them through this antenna to the cloud. All of the other data gets deleted from the vehicle. So I'm going to just show a video of what that looks like. So I mentioned a couple of things like here's what the camera sees. So you're using computer vision to not just capture the video, but to interpret what the camera sees as it travels down the street. So you can see some of these little yellow dots on the side. Those are showing where is the curb. You've got a red bounding box to say, okay, this is the presence of a dedicated red painted bus lane here. You can see, for instance, here are some boxes around vehicles. Some of the vehicles are parked and they fit the business rules, and there's going to be an evidence package. Some of the vehicles, the ones that are driving on the left-hand side, those are irrelevant. They're not necessary. So the perception engine that's on the vehicle is running these machine learning algorithms and these calculations in real time to say, is the computer vision data valid or not? And so all of these different artificial intelligence tools are operating in real time, in near real time simultaneously to figure out the problem of, is there a car illegally parked in this space or not? And what do we do about it if there is? So that's an example of some of the ways that you can combine multiple methods, multiple data inputs. So we're looking at video, we're using business rules, so language that is in effect that agencies would have given us. And we're using data and numbers, for instance, the latitude and longitude of where is the vehicle in space. And all of those things are combined in real time to actually perform an artificial intelligence task on behalf of an agency. So that's kind of a simplified example, but I hope this was helpful and sort of clarifies some of these tools. And we're going to move now with Laura into the Q&A section.
Great, thank you. Thanks, Renee. And I know we kind of flew through pretty quickly through the different AI methods, that you had on those 2 slides. So I do want to reiterate to folks that information is available in the report. So start thinking about your questions. I'm going to ask a few of Renee, but feel free to put your questions in the Q&A chat box, and we'll get to them in just a few minutes. So the first thing, before we get to questions specifically about the paper, since the president did release this executive order on AI yesterday, first of its kind, first time we've ever had anything like this, and it does cover all federal agencies and really whole of government. I just wanted to ask Renee for, what are your initial thoughts, reactions to that executive order?
Yeah, absolutely. I have a few. First, we've seen a number of executive orders from both this and the previous administration, and it's clear, and I appreciate the fact that there is a lot of interest happening at an executive level in how artificial intelligence is being developed, how it has a direct impact on, not just things like the federal agencies, which the Biden administration is able to control, but also, consumer products and how AI may impact everyday Americans. I would say the challenge of executive orders is that the job of legislating artificial intelligence really falls to Congress. And so while I think this executive order is important, it probably won't meaningfully have any impact on private sector and consumer related products. But for us in the transportation industry, there are opportunities to see changes. One thing in particular that was called out in this executive order is there was this phrase, the effective government use of artificial intelligence. So that is so the Biden administration is calling on federal agencies, obviously including USDOT, to issue guidance on how they plan to procure AI technology efficiently and safely. And so I think that is something that we're likely to see have a direct impact on, either folks who are, leveraging federal dollars if they work in state and local agencies, or someone like myself who might be a vendor who works with government clients. So I think that's likely one of the primary impacts from this act. I would say more generally, one thing that you see in this executive order is that although Congress may not have passed any comprehensive artificial intelligence regulation, we have a lot of laws that are already on the books that are being used to regulate artificial intelligence in all forms of technology and software and hardware services that government procures. So for instance, the executive order leveraged the Defense Production Act for part of its guidance on national security. For instance, so I mentioned the Hayden AI solution. There are longstanding case law, both federal regulations and then Supreme Court law on, what are public rights and private citizen rights when you're in a public right of way. And so there is a lot of existing regulation that agencies are able to leverage to understand, what should I know when I'm looking at AI? How can this company describe to me why the artificial intelligence solution that they're pitching to me, fits within the regulatory framework that I have to abide by as a public sector employee. And so I think that there's already a lot that's in place for those of us in the transportation industry that really doesn't exist for people that work only on the consumer side.
Yeah, you make a good point there. And I want to actually ask a question that you kind of sort of just answered a little bit of, but see if there's a little bit more there, which is, in the paper, and you just mentioned, there's additional challenges and requirements that public sector agencies have, right, when using AI or procuring AI. And so, what are some of those requirements, and what have you seen public agencies do to address those challenges?
The regulatory piece is hard to answer because there's such a large amount of existing regulation that agencies work with, starting at the federal level and adding to it at the state and the local, depending on where the agency is. And there's a ton of variation, aviation and what FAA may regulate compared with Federal Transit Administration, which in some ways has less at the federal level and maybe more regulation that comes into play at the state and local level. So I can't really give you a list of what those regulations are. But in my work, I have found that we have, as someone who works at an artificial intelligence company, we're aware of the broader regulatory framework. And so the solution that we're developing and executing fits within that larger regulatory framework because there's nothing specific to artificial intelligence. Does that make sense?
Yeah.
Yeah.
I know it's a hard question to answer. It's not a one size fits all question. So let me actually go to a question in the chat, which is a question directly about Hayden AI, which is, how does this tool deal with obstructions in the bus lane?
Yeah, so the way that our solution works to date is we provide an evidence package to the agency that's responsible for parking violations. Usually that's a Department of Transportation. Sometimes it's a parking authority. And that agency does a traditional parking violation process. What we have seen in New York is that the recidivism rate, so the number of people that commit a second violation, it's about 14%. So 86% of people appear to be changing their behavior and not parking in that space again. And that's the method that we've used to date.
Interesting. Let me go to another question in the chat here. We've got some good questions, so I'm gonna prioritize these first. So among the various methods of learning that were cited, mentoring has been shown to be successful with other technologies. Is mentoring a technique that could fit into AI learning?
I think mentoring is a more challenging way to try to teach about AI. So for instance, for me at Hayden, I was able to learn a lot about AI because I got a new job at a company that does it. And so I learned by learning about the product and from talking with folks on my engineering team. But I think more general in terms of like upskilling or capacity building in artificial intelligence, I think something a little more formal would probably be necessary to really get a good grounding. So one of the sources that I cite in the paper that I found the most helpful is an online course called Elements of AI. It's actually through the University of Helsinki, but it's done in English. And that was one of the most useful sort of capacity building exercises that I went through in the course of writing this paper. But I think it might need to be something more formal, like a continuing education class at a university or some other sort of online learning method. I think also because the nature of AI is so complex and the use cases for when and where it's appropriate in transportation can be so varied. These general tools will probably be really helpful, but you might also just have to do your own sort of research and Googling to solve a specific problem that you may have in your own work. Just because I think that's the nature of like how the technology is advancing so quickly, and how people that provide like educational opportunities are trying to keep up with the advancements that are taking place.
Yeah. So what would you say to people who are concerned about using AI in the government sector, people who are just saying, you know what, I don't get it, or there's just too many minefields here and I'm not going to do it? What would you say to them?
A couple of different things. I think it will be difficult to avoid using artificial intelligence in the next like 5 to 10 years. And so learning about it, demystifying it, and understanding it a little better now, I think is really important for your own professional development. In terms specifically of risk management, I think one of the most important things about applying AI in a government space is keeping a human in the accountability and in the decision making. So for instance, thinking of AI as a tool that helps me do my job better, maybe removes some of the sort of busy work, or some of the, less just the paperwork that really, is at a lower level than the way that I might like to be spending my time. That's one of the ways that AI can help. But I think in a larger sense, as long as you're clear that a human is making the decision, particularly when you're talking about, government, and the fact that, government agencies are accountable to taxpayers and to elected officials in a way that your Netflix recommendation engine is not. And so the level of rigor for oversight and accountability is just higher in government. And, the easiest way to manage that for now is to keep a human in the decision-making loop, and not to cede accountability to an AI tool and assume that you don't have to act and that you have no responsibility for a tool that's acting on behalf of an agency, or that has work being done on behalf of an agency.
So that kind of segues into this question about, how do we develop trust in AI models, and what are the prerequisites? And I've heard people say, to develop trust in it requires transparency, but from your perspective, you must have to answer these questions all the time, right? So how do we develop trust in these different AI models?
So some of this I think I've already answered, so I'm not going to repeat myself. I think one of the other things is, if you're working on the public sector side, holding your vendors accountable to explain to you why the solution that they want to provide to you fits within the regulatory framework that you need to operate. You should feel a level of comfort that they're able to do that, that they're able to articulate that, and that you're clear enough on how the AI works to feel comfortable incorporating it into your work. And then I also think if you're the person that, is sitting in the public agency, having enough of a baseline understanding of how AI works to be comfortable either making a procurement decision on behalf of your agency, or to using a tool that your agency has purchased, and to feel that you can use that tool and it's helping you do your work. It's helping you, solve a problem that you have, and you're still responsible for the work output that you're doing.
Mm-hmm. Yeah, I like always tying it to solving a problem, I think is really important, to show the benefits and why you're using it, the why. Let me ask you a question here. You've talked about some different examples, but what is an example or two of how AI is being used, right now that you find exciting?
this is not a specific tool. It's happening from a number of different companies, but there was a report that Federal Highways wrote 5 or 6 years ago that basically said a lot of public agencies are data rich but information poor. They already have more data than they know what to do with, but they're not getting insights from that data at the level that they could be. And so there are so many ways that companies are, both companies and then in-house data science folks within agencies, like I would say MBTA or WMATA are two examples I can speak to from my transit experience. But basically leveraging AI tools to get insights out of data sets that an agency already has access to, but either the data is like housed in a format that hasn't been easy to transfer into another format, putting it into a dashboard, combining it with a lot of other data sets to come up with a greater and a richer analytics. Anything beyond what I think some vendors have done, which is provide data to prove contract compliance, but which may not have provided a much higher level of insight for the agency that's procuring it. I would say another example, I was talking with a CIO at a large transit agency who is testing a generative AI tool to review all of the complex documentation that this transit agency is required to abide by, to basically distill from it what is actually relevant to a particular transit employee that only needs a small piece of that information. So if you think about chat GPT, which doesn't show you any of the sort of sources for where anything comes from, but that level of drawing a very small amount of personal information from a very large body of documentation, that being able to apply that kind of large language model to the amount of bureaucratic, but the number of papers, the amount of paperwork that agencies are required to use, I think that's one of the most exciting tools to really reduce the time and the complexity of ensuring that your agency is following the rules and remaining in compliance.
Yeah, I think, using, like you said, using these tools for things that either, humans cannot do, like essentially pulling these insights from these large data sets where you just wouldn't be able to comb through and get that information in any kind of reasonable time frame, or like you mentioned, the generative AI for compliance. I think those are interesting use cases that can really provide benefit, and help, as you said, kind of help the person who's in charge, right? It is a tool to help the human who's in charge and help them have more confidence in some of these decisions that they're making and the insights being provided.
Absolutely.
So, a lot of the things that you've touched on, right, talk about or lend themselves to understanding these AI methods and understanding the tools. And there's a question in the chat asking, have you found, in your experience working for an AI company, have you found that AI is more easily understood by younger professionals than by, older professionals? Is there no difference? Can you comment at all on what you've seen there?
I think there is some benefit just to being a little fresher out of school, and what you learn in an educational environment that may apply in your job. So I think that's entirely possible. I mean, when I'm thinking of the people I know that I actually look to as mentors, I'm 45 and a number of them are either my age or older. So I feel like there's I don't think it's based so much on age as on level of interest in, level of interest in technology and level of interest in, building your skill set and being a lifelong learner.
Yeah, absolutely. I think the curiosity and being a lifelong learner is so key, particularly in this space at this time where technology is evolving so quickly and so fast. Let me go to a couple other questions in the chat here. I'm going to ask you a more specific question about Hayden's solution.
Okay.
Going back to, vehicles impeding bus movement. The question is, how are the vehicles impeding bus movement moved out of the bus lane once an AI analysis is complete in real time?
So we have not yet partnered with an agency that's interested in that real-time moving the vehicle. I suspect that is something that they will come to, but it's not something that we've provided to date.
So right now it's just the ticket.
Mm-hmm.
The enforcement, yeah. Okay. Another question. Is it possible for AI cameras on buses to do the work of parking authority personnel for other parking violations? Examples would be monitoring how long a car has been in a particular spot for a 2-hour parking, or if it's exceeded its allotted time by cross-checking the license plate with data in the paid parking system.
Absolutely. So New York State this year passed legislation. I believe it only impacts New York City, but it will allow bus-mounted camera enforcement vehicles to capture double parking in addition to bus lane, and they're also adding bus stop. The city of Chicago also passed something earlier this year that would allow other parking violations. So that might be something like blocking the box in a crosswalk. So it's definitely an area that agencies are interested in pursuing. The state of California actually passed enabling legislation to enforce bike lanes. As someone who bikes regularly, I'm excited for that to come to my home state of Florida. But yeah, so state legislatures and in some cases cities, the city of Philadelphia also recently passed enabling legislation. They're interested in how this enforcement tool might be expanded.
So that I'm going to tie that a little bit to a question that's sort of related in the chat, which is
Okay.
not more about the regulatory approach, which is, are there any shortcuts to understanding the regulatory framework? I'm going to add into this also, the legislative framework that you just talked about, that may apply to any given situation, or is research required for each, individual jurisdiction, essentially?
I'm going to assume this is a private sector employee, a private sector person. And in that case, it will definitely be research for each situation. If this person worked at an agency, they could probably just walk down the hall and talk to, a general counsel or someone else on either the legal team or someone who maybe, works on federal grants and kind of understands the regulatory framework in order to execute those grants. But on the private side, it tends to be legwork, a lot of legwork.
Yeah. Another question in the chat, does AI efficiency and robustness depend on the amount of data being collected and processed?
In general, yes. Yeah. So that's partly why the question or the tools of like reinforcement or supervised learning, unsupervised learning, because machine learning algorithms get smarter the more data they have access to, the quality of output on a smaller data set is almost always going to be less than a larger data set.
Let me ask you this one, Renee, because I know you have experience in many different areas of transportation. And even though your solution or Hayden's solution is focused on transit, the question is, what are some areas where we'll see, I think they say where we'll see in traffic management centers, I think, AI applications in traffic management centers. Go ahead.
Yeah. I'm still impressed with the tour I took of the GDOT Traffic Management Center, which is just a couple miles from downtown Atlanta pre-COVID. I think a lot of the area. So at the time, this is pre-COVID, and GDOT already had real time, folks sort of watching these monitors, managing traffic in real time, I think they had at the time sort of particular lanes that they could open or close based on, a sort of significant out of the normal event that might heavily impact traffic. I think a lot of the opportunity to apply AI to that would be in um, using the data that's been collected in those TMCs over years to make decisions around how do we need to maintain the road network we have. If we're doing something like traffic signal priority, what are some changes that we need to make to that? How can we manage the level of vehicular congestion that we're seeing? I think agencies are still trying to respond to the sort of post-COVID travel behavior changes that, we probably thought we had a good handle on, but as the return to work from some companies continues to ramp up and increase, I suspect that there's a lot that could be learned from more insights into, we don't really understand the traffic pattern that's happened in the last 30 to 60 days. Is there another like period in time that this looks similar to, and how can we use what happened in that period to change decisions that we might be making about something like a transportation demand management program, or the sort of or even more real-time operational changes. So I think it would be more in the data analytics than computer vision in those centers.
Yeah. Well, and I think we all know, I mean, there was an article in the Washington Post, maybe, I don't know, a week or so ago, talking about how the Washington area commute has gotten worse. That's, not unique to Washington, right? To many, many cities across the country. And to your point, travel patterns have changed, and there's a lot of shorter trips, and there's still an enormous amount of congestion. And agencies are trying to figure out how to manage that, how to mitigate that, and why it's happening in different areas. So these could be useful tools to apply. All right, let's see. We've got a couple more new questions in the chat. So let me ask you one that is focused on cybersecurity, which is, what measures are being taken to mitigate the cybersecurity risks associated with AI implementations in transportation, and how do you ensure the security of critical transportation infrastructure? It's pretty broad.
It is. And cybersecurity was, I think, probably in every executive order, but certainly in the one that was released yesterday. Strengthening cybersecurity is part and parcel of any sort of artificial intelligence regulation. There's a couple of different methods for this. One of them is, so the three major cloud providers, so Google, Amazon, and Microsoft, they invest pretty heavily in cybersecurity, I believe voluntarily, but because of the risk of any sort of data breach to any of their cloud clients, they have a very heavy investment in cybersecurity on the cloud services they provide. On the side of, the smaller vendor like us that might tap into one of these cloud providers, it would be thinking about, so for instance, Hayden AI says we're privacy first. So one thing that I mentioned was this idea of processing on the edge. So one of the easiest ways to reduce the risk is to reduce the amount of data that's being shared. So instead of having 16 or 18 hours of video being pushed to the cloud from the bus yard every night, only the potential violation is sent through the cloud. 95% plus of the video that's taken on the bus is destroyed within a certain number of days, and it never leaves the vehicle. And then there's a variety of security certifications. So there's a program called FedRAMP. There's the SOC 2. I do not remember what it stands for, but there's basically a variety of other cybersecurity specific certification processes that already exist for more general technology, and which agencies can require vendors to abide by.
Great, that's helpful. Another question in the chat is, how do you manage monitoring of AI systems in practice? Data changes in operations can make an AI outcome be erroneous. Therefore, are monitoring needs and cost of data maintenance, retraining of algorithms, et cetera, taken into account when selling and purchasing these products? Do AI products have a very short life in practice?
Yeah. So there's two things I would say. First of all, if you are on the public sector side, you could say, I have a threshold of accuracy, and I'm going to, some agencies will put multiple vendors in a head-to-head pilot or test process and say, you're going to share all of your data with me, and there's a certain threshold, it could be like 50%, it could be 95%, but there's a threshold for accuracy that you're required to meet in order for us to issue you a contract. So that's what you could do on the agency procurement side. On the vendor side, so I mentioned earlier the fact that machine learning makes improvements over time. Partly it makes those improvements by having a larger data set and from getting feedback through human feedback from that supervised learning process, where when you're first starting out with a brand new algorithm, you have to have some level of human review to say, this, if you think about, if you remember the CAPTCHA, so, you have a set of 9 images, you have to say which one has a motorcycle in it.
Yes, and it was
That's
driving me crazy
actually,
because I'm always like, I'm a human.
yeah, exactly. But I mean, that's basically a solution where someone is using everybody in the public that has to go through the CAPTCHA to do reinforce, like supervised learning, to improve the accuracy of their computer vision tool. And so, but what I'm saying is that the nature of artificial intelligence is that the machine learning improves over time. So when you think about an AI product having a short life, ideally, you have skilled people working on that algorithm, and the accuracy is always improving. And so the short life is probably based on this doesn't solve a problem or nobody cares about it, more so than you've been working on this AI model for 2 years and it still has like a 30% accuracy.
And if it's solving a problem, right, then my assumption, based on everything we've learned today, if it actually is solving a problem, my assumption is it's just going to continue to solve that problem even more accurately or better over time.
Yes,
Um,
yeah. Yeah.
yeah. So let me ask you a question. This is something that, you hear, I hear a lot in transportation. And since obviously you represent an AI company, we hear the terms ethical AI frameworks or responsible AI development. And so I'm wondering, from your perspective, what do those terms mean to you in practical terms? Do you hear them from, your clients? But what does that mean to you?
Yeah. Um, in the same way that the definition of artificial intelligence is constantly changing because the technology changes, these, you can use these terms to mean anything you want to. And so they're very squishy. They tend to be defined individually. And so most, if not all, AI companies will tell you that they do, that they use AI ethically and that they have, they use these frameworks and they abide by this and that. It's really when you get down to certifications or, do you have a cybersecurity person on staff? Tell me about, there's something called like as, asymmetrical like pen testing, where, we would pay a third party to try to penetrate and hack into our system. And we would receive a report afterwards that says, these are all the things that didn't work, where your security processes are perfectly in place. These are some areas where, we were able to like penetrate a small amount, and here's a change you need to make. And so there are a number of different tasks and tools that AI companies can implement And they should be able to explain those to you to increase your confidence that they have, actually, done some action to fulfill this idea of an ethical AI framework or responsible AI usage, rather than just have it as a sort of marketing tool.
Okay, here's a question that is, I think, near and dear to both of us, which is how do we ensure that the voice of end users are accounted for when planning and implementing AI-enabled solutions in the transportation space?
I think that one thing that surprised me coming into transportation from public health is there is not as much of an understanding of, the traveling public or, individual travelers compared with how public health is practiced by public health agencies. So I think there's opportunity on the agency side and on the vendor side to better understand those end users. I think the methods can really vary. So, if you're someone at a technology company, you would do something called user testing. So, you might build a prototype of a solution, but at some point you're going to want to have it looked at by someone who, could be a potential client to tell you, I don't understand this. This is useful, but this isn't. Ideally, you might also have someone on staff who has experience working in a public agency that can help you inform your product development process before you ever show it to a potential client. But I think in terms of end users, so an actual traveler, I think AI can help improve that level of outreach because you can do things like take public comments from social media and try to distill them to, for instance, like understand power outages or service disruptions in real time. So that's something that, large agencies have been doing with Twitter feeds for, 5 or 6 years. And I think there's probably a lot of additional AI improvements that could be applied to that really rich data set, as well as to say, how many people writing transit are using Twitter? Who are we not reaching if we're using this as a primary source for end users? What are some, text-based tools or even something? I think one thing that's important to consider is technology may not be the solution to the problem. If the problem is understanding what the user needs, that may be something that has to be gathered with an in-person focus group or tabling at an event. And it may need to be something that's done by a public agency and not by a technology vendor that, would struggle a lot to get that level of feedback.
Yeah. That's very well said. And I will say that, as you know, we've talked for a while at ITS America and our members, we've talked a lot about the need for really robust engagement, community engagement and public engagement. And we know that transportation agencies do public engagement, but with the amount of technology that's in the system now, with the amount of new tools available, with the amount of new ways to move, right? That we're seeing, and new patterns of movement. It's really important to be engaging those communities, and these AI tools are no exception, right? They should be a part of the conversation as agencies and communities are looking to potentially employ them to solve problems. I do want to ask one more question. We have time, maybe one or two more. I remember seeing this in the paper recently. But the question is, recently in Louisville, Kentucky, the new bus route powered by AI stranded many students to the extent that administrators had to cancel school for 2 days to get the issue resolved. It's very easy to quickly tell in this scenario where AI has gone wrong. Do you foresee any situations where we might use erroneous AI outcomes and may not realize it, perhaps for a very long time, to the detriment of some entity? Obviously, in this case, the mistake and the was evident right away, and the fix was pretty quick, but it's an interesting question.
Yeah, I actually missed that. That is a big,
Oh yeah, I remember seeing it thinking,
gosh. Oh wow. I don't know how I missed that. Yeah. Um, I will say that I'll just say one thing I really appreciated. The second Hayden AI client is WMATA, and WMATA took a very thorough approach to their procurement, which included releasing an RFP that did go through, that included a head-to-head pilot of the tool, believe for a 60-day period. They had that evaluation process to fully understand what the tool might look like in a test environment before it was deployed in real life. And they were able to learn enough from a test implementation to be confident with a larger deployment. And I think that sort of multi-step, starting with like a sort of maybe a desktop exercise of, just show me a demonstration of what this technology looks like, moving towards, I'm going to let you try it on, one or two buses, and I'm going to track it for a few weeks, and I'm going to see what I think about what you're showing me. Does it fit what I saw in the demo? I'm not sure how that would be a challenge to have, to fully roll out a root configuration and have it backfire like that. And I wonder if a more iterative process might have prevented that.
might have prevented it. Yeah. I will say one potential answer to this question that I have before we close is I was actually talking, you know Victoria Sheehan very well, director of TRB, and we were talking about AI on a panel, and Renee, you're very familiar with, we've always talked about how a lot of times the data that we collect in transportation doesn't really represent how it doesn't represent how women want to move. It represents how women move with the system that we have, where it may not be really tailored for us, right? We have to trip chain to kind of accomplish maybe our caregiving responsibilities and other responsibilities. It's not really set up for a lot of women and how they need to get around during the day. And we were talking about the fact that if we're using AI models to improve efficiencies in the system, or even to create routes based on the data sets that we have, will that negatively impact women? Because right now, the data sets that we have don't really work well for women. And so how do we get to a point where we actually get the information about how, for example, and that's not just women, but certain different communities, how do you want to move? How do you want to be able to travel? If the only data that we have is based on, let's say, systems that don't maybe serve all communities equitably or as well as they should, then our outcome, right, is not going to fully solve that problem. So that would be sort of my answer to that question. And it might take some time to get to that point where we figure that out, right?
Yeah. This one specifically, what I would do is leverage data sets from, take a country maybe in Scandinavia, or a place where the quality of transportation or the quality of satisfaction that the riding public has with transportation is higher. Look at how the system is different, how the operating hours are different, and how a lot of other things are different. So for instance, one of the challenges of transportation are we deal with negative externalities from a lot of other decisions, like land use, where do people live. We also deal with the fact that, yeah, we have a system that was built thinking about white collar men commuting to and from work, and that thinking more about who's left out from a particular data set, and how do we either find that data or find a proxy for it to think about the imperfections in the data and analyze it differently with a different kind of data, maybe from outside transportation. would be the way that I would try to tackle that.
Well, thank you so much. We are at time, but this was a really interesting conversation, and I really appreciate you taking the time to share your work with us, share more about Hayden, and generally opine on all things artificial intelligence.
Thank you so much. I'm so pleased to have had this platform to talk a little bit about my paper, and thanks so much for everybody who participated today and showed up.
Yeah, well, thank you so much. Thank you, everybody. And we will make the recording available online, and hope everybody has a great rest of their day, and happy Halloween.
Happy
Bye-bye.
Halloween. Bye.